Hey y'all, today we're going to talk about graphing equations. And if you want to hit pause, go ahead, grab some graph paper, sketch out. I did increments of 1, and you can tell mine's not even at all. 1 stops at 12, 11, 15, 14. Just sketch out something to get yourself a good amount of graph sheet. And let's go ahead and get started. So anytime we are graphing equations, we need to write down a few helpful hints and tips to get us through graphing these equations. So here are some tips that will help you. Anytime you're graphing, you want to make sure that your equation is in slope-intercept form. Go ahead and write that down. Okay, so what is slope-intercept form? We went over this on another video. If you need to reference that, it is just the generic slope lesson. So tips right here, slope-intercept form. Our slope-intercept form is always going to be y equals mx plus b. Okay, so now we need to go over the different parts of this equation, the formula for slope-intercept to make sure that you're graphing it correctly. So the m is always our slope. The b is our y-intercept. Now, our y-intercept, it means that that number is going to fall on our y-axis. So let's go ahead and put in parentheses. That is going to be our starting point when graphing. So our y-intercept is on the y-axis, and that's our starting point. Our slope, you always follow this other tip in order to graph your slope. Rise over run. So our slope is going to be our growth. And that's going to be how we move. What do we do each time as we are moving on this graph? So let's go ahead with a few examples. And let's graph these. I'm going to be graphing in different colors so that it's visible and you can see everything. The first one that I'm going to start with is just a generic linear equation. So y equals 3x plus 4. Y equals 3x plus 4. Now, my starting point, my y-intercept, where I'm going to start, is that plus b. Well, in this particular situation, 3x plus 4, my y-intercept on the y-axis is 4. So I'm going to go to positive 4 because it's a plus 4. And I'm going to make my first dot. You can't see it very well on this graph, but there is a dot there at 4. 3 is my slope. In order to follow the rise over run, 3 is a whole number. So how do I write 3 as a fraction if it's a whole number? 3 over 1. Because it's a whole number. So that means every single time from this point, I'm going to rise 3, run 1. So 1, 2, 3, run 1. 1, 2, 3, run 1. I can't go any further. I've run out of room. So what you can do is you can go back to your initial point and you can do the exact opposite of what you just did. So instead of rising 3, running 1 to the right, we can do the same, the opposite. We can go down 3, left 1. Down 3, left 1. Down 3, left 1. Okay, that looks like a good amount to show. So I'm going to line my ruler up nice and neat, real perfect. And I'm going to draw my linear line. All right, let's try another example. So what if we have y equals, what if it's negative? So y equals negative 3x plus, let's say plus 4 again so that you can see that. Y equals negative 3x plus 4. Well, my initial value is my plus b. I'm going to start at 4, make my first dot. Because it's a negative, how would you write negative 3 as a fraction so that you can rise over run? Well, that would be negative 3 over 1. That's your fraction. That's your rise over run. Instead of rising 3, because this is negative, you're going to drop 3 and run 1. Now, notice here, I did not drop and go left. You always run to the right. The only time you run to the left is when you're showing opposite value. So go down 3 because it's a -3, run 1 to the right. Down 3, run 1 to the right. Down 3, run 1 to the right. I want to show some opposite value so that I can have a great line going all the way across my graph. So go back to your starting point. Showing the opposite, you're allowed to go to the left. So 1, 2, 3, left 1. 1, 2, 3, left 1. The only time you run to the left is when you're showing opposite value of your slope. Put your ruler up, draw you a line. Now, if we were judging steepness, which of these two lines would have the steeper slope? A +3 or a -3? Hopefully you've watched my other video on slope, and anytime you're talking about steepness, you ignore negatives and you look at the absolute value. So 3 is 3. Both of these lines would have the same amount of steepness. All right, so let's change to some fractions. What if you have a slope that is a fraction? Y equals 2/3 x plus 1. Y equals 2/3 x plus 1. Can y'all see those? Okay. Y equals 2/3 x plus 1. So your starting point on your y-axis is a +1. I'm going to start right there. Rise over run, 2/3. It's already in fraction form. The only time you put it in fraction form is when it's a whole number over here. So because this is already in fraction form, I rise 2, I run 3. So this is going to look a little more slanted. It's not going to be as steep. So from that 1, I'm going to rise 2. 1, 2, 3, run 3. Rise 2, because it's a rise 2, run. So if I rise 2, run 3. Rise 2, run 3. Like I said before, if you want to show some on the other side of your graph, do the exact opposite. Instead of rising 2, running to the right 3, drop 2, run to the left 3. Drop 2, run to the left 3. Like I said earlier, you always start your graphs going to the right. The only time you go to the left is when you're showing opposite the backwards value. So notice that this line is not as steep because 2/3 has a smaller, greater value than a 3. All right, let's throw in a few other examples. Let's throw in a line. What if your equation was y equals -7? Y equals -7. Do you have any slope here? Do you have anything connected with an x? You only have y equals -7. So on your y-axis, go find -7 and make a dot. Do you have any slope, anything connected with x at all? No. It's just y equals -7. So this would be a 0 slope line. You would create your line going straight across. 0 slope. Again, in my slope video, you will see how that needs to look. You'll see that on the 4 types of slope. Let's go ahead and do one more random type of slope. Let's do an undefined line. Anytime you have an equation that has x equals, let's do 12 because it's over here by itself. X equals 12. On the x-axis, you're going to go find +12. On the x-axis, notice this is different this time. It's different because there's not a beginning linear equation saying y equals. It's not slope-intercept traditional form. X equals 12. On the x-axis, I found that +12. I don't have any kind of slope. I don't have any kind of growth happening here. It's just x equals 12. So you're going to draw a straight line up and down. That's what an undefined line would look like. Going back to the 4 types of slope in my slope video. Now, what if you have a slope that is negative something, but it starts in the negative area? Easy. Excuse me. Just follow your rules. So what if I have y equals -3x minus 5? All right. Starting point. My initial value on the y-axis, -5, because that's -5 there. So I'm going to make my first dot at -5. My slope is -3. How do I write that again? -3 over 1. So you would go down 3, right 1. Down 3, 1, 2, 3, right 1. You always move to the right. Always. The only time you move left is when you're showing opposite value. So let's show some opposite value. Up 3, left 1. Up 1, 2, 3, left 1. Now, draw your line, and you have a negative line again. Negative slope, and it started in the negative region. I hope this helps. I hope y'all have a great day. Bye.